Okay, welcome. In this video I'm going to walk you through how to create a spreadsheet that will give you the miter angle, the bevel angle, the plumb cut, and the cheek cut, and I'll show you how to do that. So right here we have a typical spring angle of 38 degrees for a molding. I'm just using it because you can check it against the book. But it'll work for any angle because it's a spreadsheet. And then I'm adding the length and the width of the material, or the height, the diagonal length of the material, the diagonal height of the material, and then the width, in case it's a beam and you can't put it in a miter saw. So let's say it's a beam and you just know saw that will handle that size material. Okay, and then also we have an exterior angle here and the interior angle. So it's the same cut, the angles are the same, they're just cut in different directions. So this 243, if you put that in there with this formula, it will give you 58. It'll split the angle, so you'll get the 58.25. And it's just saying that if it's over 180 degrees, then you're gonna subtract that angle from 360 and then divide it by 2, or you're just gonna divide that angle here by 2. And then what we need is this information here. So looking down, let's say this is a side view, the top distance right here, if this was folded around the way it was in real view, 7.388. So you have 38 degrees and 12-inch diagonal, and then that's the sine over the hypotenuse, and that would mean x, the unknown here, over the hypotenuse is the sine of 38 degrees, and then you little algebra, you get your sine of 38 times 12, and it gives you 7.3879 right there. Right, this is the formula you would use in Excel. And then the same thing here, it's just that this is the 38 degrees this direction and the unknown's here, so you're going to use the cosine. This is the unknown, so cosine is adjacent over the hypotenuse, and then x over 12 is the cosine of 38, and then you get your little algebra, you'll get your 2.36. That's this distance here. And those are going to get used over this direction. So this actually, technically, it's kind of Control H, Enter. It's actually going more like this, F4. It's a little bit overlapped. Control R. So it's this portion of the triangle, really, right? Because that's easier for projection into the material. Math is the same. And then let's go to the next. So we're looking at, now we need to calculate this distance here and this distance here, right? And we know this angle, 58 degrees, and we have the height, so we can figure out what's the cosine of this. So let's go to it's what color? Green. So the tangent, oh yeah, so this, the rise over the run is going to give you the tangent. So green. So we have the rise, 2.36. Wonder why that's green. Oh, that's oh yeah, because we're getting green. So it's the orange one. So that to calculate the green, we're going to use this 2.36 right there over x is the tangent of 58, and then multiply. So then, you know, to get the equivalent, you're going to go 2.36 divided by, it should be divided by, tangent of 58.25, and that'll give you 1.463. Yeah, B8. So this is in Excel, B8. 2.36 divided by B6, which is the bevel angle, or the corner angle. Or the corner angle divided by 2. And then, so that's where we're at. Now we got the cheat cut. So what we're going to do is we're going to calculate this cut. So this is like a can opener view of the piece. So this is the front and that's the top. So this distance here does not change when this piece is moved up and down, because it's this is like a hinge point, so it doesn't change as this thing moves, right? So while we're looking at the top here is oblique to this distance won't change. We're going to use that and project it down onto the 3-inch width here. All right, and then we're going to go 1.46 over 3 will give us the tangent. So we're going to get the arc tangent to that. And that's the green. Yeah, so arc tangent of 1.463 over 3. And that'll give you the angle 25.996. 25 point, ooh, that's interesting. Oh yeah, this is the cheat cut. So that's the cheat cut. It's not the bevel angle that you would set if it was on a table saw, or if you were using a table saw or a skill saw, or the dihedral angle. That's not the dihedral angle. All right, and then, but it is the calculated cheat cut angle. So looking at the surface, it would be that. If it was just a regular square cut here, it would be the right angle, but it's not. It's called the cheat cut angle, I think. I don't think that's slang. I think it's actual name. And then we got, so now we have that. And then we have this 1.463 right here. 4.572. Go same as that. All right, so we're going to look at that. Divide up by 12. And that'll give us the arc tangent of that. Will give us 20.86. 20.856. So now you could lay this out on the outside face of a tube or outside of a lumber, just like you would with the framing square. You're looking up the cheat cut and then the plumb cut, and then wrap it around and cut it with your saw. If you want the dihedral angle though, like if you wanted to set typically on a roof rafter, since the usually not on a bastard hip roof, but on a regular roof, it's at 45 degrees. So the dihedral angle is 45 degrees. It doesn't matter how steep it is. But if it's an odd like this, you have to calculate the dihedral angle, which is kind of done like this. So what I'm going to do is zoomed out here. Kind of it's in the own thing. So this is the cheat cut. It's been folded away, so you can't see that cheat cut on the top. So this is just a perpendicular to this face, a flat cut. And then what we need to do is calculate this distance right here. So we have this one 1.463, and we know this angle is 20.856. So even though we're working with this one, it's this angle, right? So this one here, alpha MA, is going to be the same as that. Right? It's the same as this one. It's a little tricky not to get it confused with this one. Right? It's not that. It's this angle. So that triangle there, we have this distance. So let's just do it. I'm going to draw it up. So this is the deal, right? It kind of looks like this. And we have this distance is 1.463. And then we're looking for this distance right here. And we have this angle, 20.856. So x over the hypotenuse will give us a cosine of 20. So x over cosine of x over 1.463 is equal to cosine 20.856. All right, and then he just cosine of 20.856 times 1.463. And then we calculated that one. And then let me look at this up here. Yeah, it's right here. Cosine times that. Cosine of 25.856 times 1.463, 1.367. All right, that's this distance right here, 1.367. All right, that's what we were trying to. That's what 1.367, and then equals 1.367, and then that over the 3 will give us the dihedral angle, right? So arctangent of that over 3, 24.98, and 24.98. That is the dihedral angle. Perpendicular to the dihedral, you're just looking at you're kind of looking through it, and you need to know what the distance is between this one and the thickness of the material, so you can calculate the dihedral angle. Miter cut angle, I don't know, let's see, 20.5856. So if it was laying flat on the table, that's the miter cut angle. The dihedral angle would be the bevel angle. I guess I could have called it the bevel angle. And that's it. So let's go real quick to Excel. And then, so that's it. Let me go through right here. I'm just going to scroll through these so you can pull up the formulas just the way they are in case I've made a mistake since I've moved some stuff around. All right. Right there. Those are the inputs, right? And then we get into the calculations. That's it. Takes care of it, whether it's an inside corner or outside corner, or yeah. And then that's looking down on the material for the spring angle between the wall and the edge, or the bottom and the face. That's the plan. I don't know, plan of the thickness. Yeah, the thickness of the material looking down at an angle. That'll give you that number right there. And then there's the cheat cut. That's the rise and run, basically, for the face of the cut, the cheat cut angle. And then miter cut difference. So this is the kind of like the rise and run of the material there. So if this is 4 and then this is 12, so if you go 58, how does that work? I think it would have the 12 in there somewhere. Tangent radians of these, and I guess this one's using the 12. I'm not sure. Let's see, miter cut. But anyways, you can see where it got done here. Tangent radius B6. Let's look that one up real quick right here. This is this, this is this, and this is that's the one that's been calculated. I thought that's what we were looking at. No, so this one, yeah. So that we went through that. Get back to it. There you look at that again. I already went through these, so just pulling up the formula. Like I said, in case one of these numbers was moved, since I moved some stuff around to get it more in order. And then there. And there. All right, so let's do this. Let's say 41 degrees. And then the corner angle is let's do 300. 6, and we leave that 12. Let's go 224, right? So if it was a huge beam, 6 by 24, and then all this is done math, it's calculations, right? So let's look at this. If I go to this here and go into 3D, I'm just going to create something like this. Let's see, so let's make a box. This will be our beam. And it's going to be uh, 24 high, no, 24 high, 6 wide, and we'll just say 48 long. All right. Now we're going to look at the cheat cut. The difference in the cheat cut will be 7.832. So copy. V. Okay. Enter, and then I'm going to say use selection handle, and then the length will be Control V. And then this is the cheat cut. Enter, Alt M A. $52.85 or 52.58, so that's good. And then the plumb cut will be miter difference. Big Control C. V. And then I'm going to copy that, Control right to there, Control V. All right, V like that. And then, so this would be right there, Enter, Control C, Control V. That's our cut looking like that, right? So we'll just take this, go like this, Control H. All right, and that looks crazy, but let's do this, Control, and then flip that to custom mirror. And then right here should be Alt MA 300 outside, right? $60, so 360, so yeah. I don't know why that came out like that. Let me see what this looks like in 3D. That's all made, right? So we're looking at 41 degree spring angle and 300 degrees. Let's put that on something that's level. Control H. So Alt MA, this should be 300. Right there's 300, 299,999. And then the spring angle should be right here, V, H, Alt MA, and we'll have 41 degrees. If it's right, yeah. So 41.001. So that's how it works. I mean, it's pretty reliable. It's going to be better because, you know, some of your programs will just give you the angle, which is good. If it's going to fit on a chop saw for crown molding, it's great, but for large beams, it would not suffice. And you would need to actually scribe the plumb cut and the cheek cuts. And that was kind of a long video, but it went through every single step. I'll bet you it's a lot easier to get this watching this video than figuring it out. That's how I got it. All right. So I hope that helps in your career, and thanks for watching. Have a great day. Yeah, please subscribe. Just say that in the beginning.